Hi everyone. So today we're going to be looking at a new method to find the volumes of shapes, and this is called the washer method. So just to recap what we did last time, let's say we had some kind of solid shape that looks like this. Sorry, just give me a second. Okay, there we go. Okay, so with the disk method, we had some kind of solid shape, maybe something like this. And what we did was we cut it into disks. So just imagine a slice like this. Okay, and then we found the radius of the slice and we said what the thickness was. And if we summed up all the slices, we got the volume of the shape. Okay, so this was using the disk method. Okay, but some shapes you can't use the disk method. And for that, we use the second method called the washer method. Okay, so let's do a little example just to illustrate when we need to use the washer method. So let's say we have the following setup. We have a parabola, y is equal to x squared, and we've got another parabola, y is equal to 2x squared. Let's say we cut it off at the top at y equals 1. Okay, so we got y equals 2 squared, y equals x squared, and y equals 1. Okay, so imagine we take this area bounded between all three curves. Okay, so I'm highlighting that in yellow. Okay, so we take this area and we rotate that around the y-axis. What kind of shape are we going to get? Well, if we imagine just taking this outer parabola, the y equals x squared, if we rotate that around the y-axis, we're going to get that usual bowl kind of shape, something like that. But now we've also got this inside parabola that gets rotated around. So we end up with not a solid shape, but now it's going to be hollow inside. Okay, so the dotted line means it's inside. Okay, so we've got some kind of bowl with some thickness here. Okay, and it's a hollow bowl, so you can put stuff inside there. Okay, so using the disk method, we could find the volumes of solid shapes. Now, if it's hollow on the inside, we can no longer use the disk method. Because if we were to try and use the disk method here, imagine we cut this up like we're using the disk method. We have a problem because the disk method includes all of this volume. Okay, it's a solid disk. But now there's a hole in the middle. So we can't use disks anymore. So instead, we use what's called a washer. Okay, so if any of you have fixed a leaking tap before, you've seen a washer. So a washer is something like this. It looks like a little disc, but it's got a hole on the inside. Okay, and then this outside part that's filled in, and there's a hole inside. Okay, so this is a washer. Okay, and you see this is very similar to what we need when we're slicing the shape up. If we make horizontal slices to this shape over here, we're going to end up with a bunch of washers that are going to be stacked. Okay, because we've got this hole on the inside, these elements that we're going to stack up, they must also have a hole on the inside. Okay, and that's the whole idea of using the washer method. If your object is hollow inside, then a horizontal slice will also have a hole inside. So we have to use these washes over here. Okay, is there anyone that's not understanding the difference between these two methods? Okay, so pretty simple. Okay, so let's carry on with this example and use this new method because we've got this hole. Okay, so what we want to do is look at this and now cut it into a washer shape. Okay, the horizontal slice will be a washer. Now, if I just zoom in on this washer picture, okay, so again, it's going to look something like this. We can see that this washer has what we call the inside radius. Let's just call that R in. And it has an outside radius, R out. Yeah, so that's how we define the washer. It's got some inside radius called R in, and it has some outer radius, R out. Okay, what we want to do now is find the volume of this washer. Remember, it has thickness dy. So the volume is going to be, well, we need to take the area of the washer times its thickness. That gives you the volume. So what's the area going to be? Well, it's going to be the outside area using R out. Okay, that gives you the full circle area. But we need to subtract this inside area because that's a hole. We need to subtract this inside part. So what do we get? We're going to get pi R out squared. So that gives you the full circular area, but we need to minus the hole. So that's going to be pi R in squared. Okay, so that's the area of the surface. Okay, this blue area here. And to get the volume, we times the area by the thickness, we get dy. So this is the volume of the washer. Okay, any questions about that? Okay, so R out, remember that gives us the total area, but since there's a hole in the middle, we need to subtract the hole from the volume, and that gives you the volume of the washer. Okay, now that's just a single washer. Remember, we are stacking them up to make the shape, much like how we stacked the discs up to get the shape. So to get the total volume, we need to stack them up. In other words, integrate. So it's going to be the integral from A to B, pi R out, so that's the outer radius squared, minus pi R in squared, so that's the inner radius, dy. And remember, this is with vertical stacking. Okay, so if we're stacking vertically, we integrate along y. If we're stacking horizontally, we integrate along x. Okay, but for this example, you see that we are stacking vertically. Okay, any questions so far? Okay, so let's carry on with this example. So we've got the formula that we need to use. Let's find out what these radii are. Okay, so let's just zoom in here so we can see. So we've got our shape, and we now need to find the inner radius and the outer radius. So from our axis to the first parabola, this is going to be the inner radius. From the axis to the outer parabola, that's going to be the outer radius. So we've got R in, we've got R out. Okay, so inner radius and outer radius. Now, if we look, we are moving along the x-axis here. So to find the inner radius and the outer radius, we need to solve for x. Okay, so the inner radius, that was this formula. That was that parabola, sorry. the outer radius, that is this parabola over here. And remember, we need to solve for x. So let's do that. Okay, so for the inner parabola, what do we have? We have y is equal to 2x squared. But to find the inner radius, we need to solve for x. So we can divide by 2. And we can take the square root. So this is going to be Rn. That's the inner radius. Okay. What about the outer radius? Well, we need to look at the outer parabola. That had the formula y is equal to x squared. Okay, but to find the outer radius, we need to solve for x. So we take the root and we get x. And that's going to be the outer radius. Okay, so we've got the inner radius and we've got the outer radius. Any questions so far? Okay, so let's take everything we know here and put it into our formula. So the volume is going to be the integral from 0 to 1 because the y values are going from 0 to 1. That is the height of the shape. Okay, it goes from 0 to 1. So that's the height of our stacking. Then we've got the pi, r outer radius squared, minus r inner radius squared dy, because we're doing vertical stacking. So we can take the pi outside, and we have the integral from 0 to 1. R outside squared, that's going to be root y squared. Minus r in squared, r in was root y over 2. Squared dy. Okay, so everything's nice and good because everything's in terms of y, which is what we wanted. So let's do the integral. So we have pi integral from 0 to 1. Root y squared is just going to give us y. And root y over 2 squared is going to be y over 2. So we have pi integral from 0 to 1. 1 minus a half is a half. So we're just going to have y over 2. We can take the half out and then integrate. So that's going to be 1/2 y squared from 0 to 1. So that's going to give us pi over 4 units cubed. Okay, that's going to be our volume. Okay, any questions so far? Okay, so it's very similar to what we did before. So like the setting out and the working is very similar, but now instead of finding a single radius like we did last time, we now need to find the outer radius and the inner radius. Okay, so the disk method, you only had to find one radius. With the washer method, you need to find 2 radii, the inner one and the outer one for the washer. Okay, let's take a look at another example. Okay, so let's say we've got this, root x, and we've got the straight line y equals x. Okay, and we're rotating around the x-axis. Okay, so this is going to give us another shape, and it's also going to be hollow on the inside. So here's the area from 0 to 1. Okay, we're rotating around the x-axis, So that's going to give us something like this. Okay, we're going to have a round opening there, a parabola kind of shape. And then this dotted line here, that means it's on the inside. Okay, and then this inside part is hollow. Okay, so this shape has some thickness to the walls of the shape. Okay, but it's hollow on the inside. Okay, so it's kind of like an ice cream cone. If you imagine it being hollow on the inside, and then the sides of the ice cream cone have some thickness. Okay, you can put stuff inside there. Okay, that's the shape that we get. Okay, but what we want to find is the volume of the shape. So remember what we need to do. We need to find the inner radius and the outer radius. So the inner radius will be from the axis going outwards to the first function that we meet. So if we go outwards here, it's first going to hit the straight line. So that's going to be R in. That's the inner radius. What about the outer radius? Well, that's going to be this one over here. It's going to be R out. Okay. Is there anyone that's confused about finding the inner radius and the outer radius? Okay. So R in is going to be equal to this line. So it will be equal to y, which is x. Okay. Why am I writing it in terms of x? Well, because we are going to stack along x. Okay, because that's the axis of rotation. So whatever your rotation axis is, that's the variable you need to use to find R in and R out. Okay, exactly the same as we did with the disk method. Okay, what about R out? That's going to be equal to y, the outer one, and that's root x. Okay, so we've got the inner radius and we've got the outer radius. Now we just need to use that formula. So the volume is going to be equal to the integral from 0 to 1, because x goes from 0 to 1, pi r out squared minus r in squared dx. Why dx? Because that is our rotation axis. We are stacking along the x-axis, so we integrate along the x-axis. Okay, so let's substitute the two radii that we've just found. So this is going to be pi integral from 0 to 1. R out is going to be root x squared. R in is going to be x squared dx. Okay, so I've just substituted those two radii inside. Okay, so let's simplify and then we can evaluate the integral. So this is going to be pi integral from 0 to 1. Root x squared is going to be x. X squared is just x squared dx. Okay, so this is quite simple to do now. So this will be pi 1/2 x squared minus 1/3 x cubed from 0 to 1. So that's going to be pi. Sorry, just got kicked off. Let me just share my screen again. Okay, sorry about that. I don't know why it went off. Okay, that's weird. Okay, let's carry on. So we have 3/6 minus 2/6. That's going to be 5/6 units cubed. Okay, so that's how we found the volume of this ice cream cone kind of shape. All right. Are there any questions about this? Okay, no questions so far. Everyone's happy with this method. Okay, someone wants me to go over it again. Okay, sure. Okay, so we have the same setup here. We've got this top function y equals root x, and we've got the straight line y equals x. Okay, so then this goes between 0 and 1. Okay, so this is the area that we want to rotate around the x-axis. Okay, so we're going to take this area in red, we're going to rotate it around the x-axis. Okay, what kind of shape do we get from this? Well, at x equals 1, that's going to be a circle. And then the outside wall is going to be this root x. So it's going to look something like this. Okay. Okay, but it's not solid because remember, we're only rotating the red area, which means we've got a hollow inside part. Let's just put this, there we go. So this red area being rotated around gives us some kind of thickness to this wall. There we go. Okay, and then this is hollow on the inside. Okay, so it's like an ice cream cone kind of thing, where this red shaded part is the wall of the ice cream cone. So it's got some kind of thickness to it. Okay, but we want to find the volume of that shape now. So remember, we need to find the inner radius and the outer radius. Okay, so the radius will always go from the rotation axis out to the curve. So we're going from the x-axis out to the curve. So this is going to be the inner radius, okay, because it's closer to the axis, so that's the inside part. And this is going to be our out because it goes to the outside curve or the outer surface. Okay, so what are the inner radius and the outer radius in terms of x? R in is just going to be equal to x because it goes out to the line. So that's x. R out goes to the outside curve, which is root x. Okay, so that is the distance. Remember, the radius is the distance. The distance here is the y value. So the inner radius will just be x. The outer radius will then be root x. Okay, and that's all you need to do. That's all the difficult parts done. Now we just need to do the integral. Okay, so after you've done this, okay, your work is done. You found everything you need. The rest of it is just integrating, which we've done so many times now. So this is going to be the integral from 0 to 1 pi r out squared minus r in squared dx. So that's going to be pi integral from 0 to 1. R out squared is going to be x. R in squared is going to be minus x squared. This is going to be pi 1/2 x squared minus 1/3 x cubed from 0 to 1. So that's going to be pi 1/2 minus 1/3. So that's going to be pi over 6. And like I said before, you can put the units cubed. I don't really mind. Okay, but if you want to write units cubed because it's a volume, you can go ahead and do that. Okay, so that's how we found the volume. All you need to do is sketch the 3D shape, find the inner radius, find the outer radius, and then substitute into this formula over here. Okay, that's it. Everything after that yellow arrow, you've done so many times now. It's just integrating. Okay, no worries. Okay, let's take a look at something a little bit more complicated, not too much. That's the third example. Okay, so as before, I need to give you the setup. Okay, so we have our XY axes. We have the curve 6 minus x squared. So that's going to look something like that. And we have the line y equals 2. That's going to look something like that. Okay, so what is the intersection between these two? That's going to be this over here. Yeah, that's the intersection of these two curves. And we're going to take this area, or this intersection area, and we're going to rotate it around the x-axis. Okay, so that's our axis of symmetry. Okay, so what kind of shape are we going to get? So at this point here, and at this point here, if we rotate that point around, imagine taking that point, going in a circle, we're going to get a circle. So we're going to have a circle over here, and we're going to have a circle over here. Yeah, and then this parabola part, this bit over here, is going to become the surface that connects them. So it's going to look something like this. Sorry, let's make it look more like a parabola. Like that. And it's going to have a hollow like cylinder coming through. So this part here is hollow on the inside. So we have a hollow cylinder cutting through the shape. So we have like a hollow tube going through the middle. Yeah, and then the walls of this is this part over here. Okay, so you end up with some kind of bead shape. So then you can like put string through here, and then the string comes out. Okay, so we get kind of like a bead. Is everyone okay with imagining the shape and then drawing it?
No, sir, I'm not okay. Please re-explain if you do not mind.
Yeah, sure. Let's just get rid of that. Okay, so imagine, okay, so here at this point here, this point, just imagine that single point over there. What are we doing to that point? We are taking the point and we are rotating it around the x-axis. So what do you get if you have a point and you rotate it around an axis? You're going to get a circle. Okay, so that point there gets rotated around. Let's continue this x-axis along. And we get a circle going around. Is that all right?
Yes, sir.
Okay. Let's call that point A. So that's point A. What about this point? Let's call that point B. We're going to take point B and we're going to rotate it around the x-axis. So we're going to get another circle. So here's point B. We rotated that around. Is that all right?
Okay, sir. Yes, sir.
Okay. Let's do this last one here, point C. We're going to take point C, we're going to rotate it around. So that's going to give us a larger circle because there's a much bigger radius there. So we're going to get this kind of circle. Right, let's redraw that. That's point C. You agree that point C is going to make a bigger circle?
Yes, sir, I agree.
Okay, so let's just connect the dots now. So if we connect this, we're going to end up with this and like that. So that's the top of the parabola. And since we rotate it around, when the point gets to the bottom, we're going to have like this and like this. And this is going to make a hollow tube on the inside. Like that. And then we can get rid of that. Okay, so this y equals 2 line, that continues here. And if you rotate that around, you get this cylinder on the inside. Do you see how that works?
Yes, sir.
Okay, cool. So you get the hollow inside, and then this red part, that is this part over here. Okay, that's the bead, like the actual part of the bead there. And then rotating that around, you get this bottom part over here. And then that goes all the way around. So you get this, this like circle kind of shape with a cylinder or a tube going through it. Okay, is that all right now? Okay, cool, you got it. Okay, so again, we need to find the inner radius and the outer radius. So remember, this is our rotation axis. So we're going to take the radius from the rotation axis. So this is going to be the inner radius. Okay, because it's the one closest to the rotation axis. And this is going to be the outer radius. Okay, because that's the one going to the outside surface. So R in is just going to be 2, because that's this distance. This distance here is 2. R out is going to be this outside distance. That's going to be 6 minus x squared. Okay, is there anyone that doesn't see that? Okay, so we've got the inner radius, we've got the outer radius, and we're running out of time here, so I'll set this for homework. So homework, find the volume. Okay, and since we've been doing quite well with this bonus mark system, I will give you until 5 o'clock this evening. Whoever posts the correct solutions on the class WhatsApp group, you'll get 1 bonus mark for the upcoming tutorial test. Okay, for next week, Wednesday. Okay, but you have until 5 o'clock. Okay, everyone that posts correct solutions before 5, you'll be getting 1 bonus mark. Okay. Okay, so that's the homework for today. Let me just zoom out here so you can get everything. Okay, there we go. And then after 5 o'clock, I'll post the solutions so you can have a look. All right. Are there any questions about this washer method or the integral that we used? Any questions, how we got it, how you use it, anything like that? Okay, so it's not too bad. It's very similar to the disk method. Just in this case, we're looking for 2 radii, not just 1. We need to find the outer one and the inner one. Okay, so that's it for today. We will carry on with more examples tomorrow. And we will also look at the example where we use a different axis. So remember last time we did the example where I shifted the rotation axis. Tomorrow we will do a similar thing. Okay. If you do have any questions, please feel free to post it on the class WhatsApp group. Either the tutors will respond or I will respond. Or if anyone else responds, then you can also get some bonus marks that way. Okay. Cool. But yeah, if you do have any questions, please let me know, because this will be coming up in your next test, and the next tutorial test, okay, will be on the stuff that we've covered. Okay, so it's important that you understand it now. Okay, I'll see you tomorrow for the next couple of examples. Bye, everyone.